Hello and welcome to everyone. Myself Ankit. Today we are going to start the second chapter of class 7th, that is number system. In this video I will discuss about what is number system and what is its purpose. As well as I will discuss about different types of number system and their conversion. Okay? So now let us start. The first question arises in our mind is what is number system? So number system is a set of values which is used to represent different quantities. Okay, the meaning of quantities is a number of students in a class, or we can say that the number of viewers watching a particular show. So here this number is the quantity which is represented by a set of values that is called number system. Okay, so basically the number system is used for performing calculation and for counting purpose. Okay, so in the earlier time when there were no means of counting, people used to count with the help of fingers, stones, sticks, etc. These methods were not very accurate and had many limitations. So, to overcome these limitations, many number systems were introduced like decimal number system, binary number system, octal number system, and hexadecimal number system. So these all are the four types of number system. Okay, so first of all I will discuss about decimal number system. So we humans use decimal number system in our day-to-day life for calculation purpose and for means any arithmetical or logical operation we use decimal number system. Okay, so what is decimal number system? The number system which consists of 10 digits from 0 to 9 with the base 10 is called decimal number system. Okay, so in this number system we form any number, or we can say we construct any number using the digits from 0 to 9. Okay, so we can see one term is there, that is base. So what is base? Base is the total number of digits used in a number system. Okay, so if means I have already means mentioned that decimal number system consists 10 digits from 0 to 9, means a range is fixed there. That range is we can use only the digits in a number system from 0 to 9, and if we total these digits, so these are only 10. So therefore the base of decimal number system is 10. Okay, once again, what is base? Base is the total number of digits used in a number system. Okay, so in decimal number system there are only 10 digits we can use, means the range is of 10 digits from 0 to 9. That's mean whenever we construct or we are representing any decimal number, so that number will be construct by using these 10 digits from 0 to 9. Okay, for example, if we are writing the number 620. Okay, so here we can see the range means 6, 2 and 0. These all are the digits which are coming from 0 to 9. Okay, and the base of this number will be 10. Okay, so by the help of this base we can identify which type of number we are using. Understood? Next one is, in decimal system each number can be used individually or they can be grouped to form a numeric value. Means we can make the group of these digits to make any decimal decimal number, as well as we can use individual digits as a decimal number. Okay, for example 5. For example 5. Okay, so this 5 is again a decimal number. Because of this base, okay, because of this base we can identify this is the decimal number, as well as we can group digits from 0 to 9 to construct a decimal number like 55. Okay, so 55, again we will use the base 10 here, so that means this is the decimal number. Okay, so by the help of base we can identify the type of number we are using. Understood? So once again, what is decimal number? Decimal number is the number system which we are using in our day-to-day life, and this number system consists 10 digits from 0 to 9. Means whenever we are constructing any decimal number, then we will use the digits from 0 to 9. Okay, and if we total these digits, so these are 10, so therefore decimal number system has the base 10. Okay, the next one is binary number system. The next one is binary number system. So what is binary number system? This number system consists of only two digits. Okay, 0 and 1. Okay, and in decimal number system we can use the digits from 0 to 9. Okay, and whereas in decimal number system we can only use two digits, that are 0 and 1. Okay, so if we total these two digits, so these are only 2. Okay, so therefore the base of binary number system is 2. Understood? Okay, so whenever we are going to construct a binary number system, or we want to use any binary number, okay, so in that case we can combine only 0 and 1. Okay, for example 1 0 1 0 1 1 1. So these here we can see only we are using 0 and 1. Okay, by the help of 0 and 1 we are constructing the binary number. Okay, and the base of this number will be 2. Understood? So by the help of this we can identify that if there is the base is 2, so that means that is the binary number. Okay, so what is the need of binary number? Okay, so because a computer cannot understand human language. If we are inputting any decimal number in computer, so computer cannot understand that decimal number. Okay, it understands only the binary code. We all know that computer understand only one language, that is machine language. The computer cannot understand any other language, any other number system the computer cannot understand. Okay, so whatever we are input into a computer, that first that will be converted into a binary number or binary equivalent. Okay, so therefore we have to know, we have to understand that how any data is converted into a binary number. Okay, so for that we will discuss later how can we a decimal number converted into a binary number system, or we can say that how and we will also discuss, or we will also understand that how can we convert any binary number into a decimal number system. Okay, now I will explain how to convert a decimal number into a binary number. So for that we have to perform some steps. The first step is divide the given decimal number with the base 2. So why we are dividing the decimal number by 2? Because 2 is the base of binary number. So that's why we are dividing the decimal number by 2. Second step is write down the remainder and divide the quotient again by 2. and we will divide the quotient again and again till the quotient becomes 0. Okay, then the last step is write the remainders from bottom to upside in the reverse order. Okay, so now by the help of example we will understand these all steps. Okay, so for example we have 25. So 25 is a decimal number because we can see base is 10. Okay, and we want to convert this 25 into the binary equivalent. Okay, so for that the first step is divide 25 by 2, and we will, whenever we divide 25 by 2, so 2 into 12, 24, 1. So here 1 is the remainder and 12 is the quotient. Okay, so now we can see 1, that is the remainder, will be written one side, and 12 is the quotient, that will be written this side. Okay, then we have to divide this 12 again by 2, and we will divide again and again that quotient till the quotient becomes 0. Okay, next one is again, whenever we divide 12 by 2, then 6 is the quotient and 0 is the remainder. Okay, again 6 is not 0. Okay, so that means we have to divide this 6 again by 2. So 3 is the quotient and 0 is the remainder. Okay, again 3 is not 0, so we have to divide 3 by 2 again. So here 1 is the quotient and again 1 is the remainder. So now we have the situation, we have to divide 1 by 2. Okay, so whenever we divide 1 by 2, so 2 into 0, 0 is the quotient, 0 and 1 is remainder. Okay, 0 is the quotient. So now we have got 0 as a quotient and 1 as a remainder. Okay, so now whenever we got the quotient as 0, then we will stop the division process here only. Okay, so now the next step is we have to write all the remainders from bottom to upside. Okay, bottom to upside. Now we can see 1, 1, 0, 0 and 1. So this is the binary equivalent of 25. Okay, and the toppest digit is called least significant digit, and the digit which is present at the bottom is called most significant digit. Okay, so now we are taking one more example. Suppose that we have 32 is a decimal number and we want to convert it into the binary equivalent. Okay, so same steps we will follow again. 32 divided by 2. So 2 into 16, 0 is remainder. Again 2 into 8, 16, 0 is remainder. 2 into 4, 0 is remainder. 2 into 2, again 4, 0 is remainder. Then 2 into 1 and 0 is remainder. Again we have to divide this 1 by 2, so that means 2 into 0, 0 and 1 is remainder. Okay, then we have to write these all digits, these all remainders from bottom to upside. So that means the binary equivalent of 32 is 1, 0, 0, 0, 0, 0. So that is the binary equivalent of 32. Okay, so this is the way by which we can convert any decimal number into the binary equivalent. Next is binary to decimal number conversion. Okay, so for this again we have to perform some steps. Okay, so first of all we have to note down the positional value of each binary digit. Suppose we have 1001. This is a binary number. Okay, and what is the positional value of this one is this one 0, positional value of this 0 is 1, positional value of this 0 is 2, and the positional value of this 1 is 3. Okay, so these are the positional value of each digit in that binary number. Okay, then these positional values will be used as a power, power of 2. Okay, and then that will be multiplied with each digit of that binary number. Okay, so now we will understand this by the help of example. So here we can see 1010. This is the binary number which we want to convert in decimal form. Okay, so first of all we will multiply each digit by 2 with power of positional value. Okay, so the first of all 0, this 0, and we will start the multiplication from the extreme right side. Okay, this is the extreme right side. Okay, so that's why we are starting from this 0. Okay, so 0 into 2, that is the base. Okay, and 0 is the positional value of this 0 that will be used as a power with this 2. Okay, so always whenever we are using 0 as a power, suppose 2 to the power 0, then the result will be 1. Okay, so with every number, whenever we are using 0 as a power, so then always we will get the result 1. Okay, so then the result of this one is 1. Okay, so 1 into 0, then we will get 0. Okay, second digit is 1. Okay, we are starting from the extreme right side. Okay, second digit is 1 into, and the positional value of this one is 1. Okay, so we will use this positional value as a power with 2. Okay, so 2 into 1 equal to 2. Okay, next 0, the third digit is 0. 0 into 2, and the positional value of this 0 is 2. Okay, so that will use as a power with 2. Okay, 2 to the 4 into 0, 0. Okay, the last digit is 1. Okay, so 1 into 2 to the power 3. 3 is the positional value of this 1. Okay, so here we can see 2 will be fixed. 2 will remain fixed in whole process. Okay, and only the changes will be there in the positional value in the power. Okay, and at last whenever we get the products of all the digits, okay, then we will take the sum of this one. Okay, whenever we take the sum, 0 plus 2 2 plus 0 2 plus 8 10. Okay, so 10 is the decimal number, a decimal conversion of this binary number. Okay, so one more example, if we take, suppose we have a binary number that is 1 1 1 0 1. This is the binary number. Okay, and we have to convert it into the decimal form. Okay, so once again, what will you do? First of all, we will note the positional value of each digit. Okay, the positional value of this 1 is 0, positional value of this 0 is 1, positional value of this 1 is 2, positional value of this 1 is 3, and positional value of this 1 is 4. Okay, next one is we have to multiply from the extreme right side. Okay, this is the extreme right side. Okay, so 1 into 2, and the power is 0. Okay, so 0. Okay, so here 2 to the power 0 means 1. Okay, so 1 into 1, that is 1. Okay, second digit is 0. So 0 into, again the base will remain fixed 2. Okay, and this time the positional value is 1. Okay, so we will use it as the power, and then this time 2 into 0, result will be 0. Okay, next digit is 1. So 1 into, okay, again 2 will be remain fixed. Okay, and this time the positional value is 2. Okay, so 2 to the power 2, that is 4. Okay, 2 to the 4 into 1, 4. Next digit is 1. Okay, again 2 will remain fixed, and this time the positional value is 3, so that will use as a power. Okay, so 2 to the 4, 4 to the 8, so 8 will be the product. Okay, next one is last digit is 1. Okay, and this time the positional value is 4. Okay, so 2 to the 4 to the 8 to the 16. Okay, means 4 plus 1 5, means 16 plus 4 20 plus if we make the sum of this product, so what will be that? Okay, 16 plus 4 20 plus 4 24 28 29, so that is 29. So 29 is the decimal number of this binary form. Okay, so the meaning of this one is, means whenever the power is 2 to the power 3, that means we are multiplying 2 3 times. Okay, so the meaning of 2 to the power 4, we are multiplying this 2 4 times. Okay, so 2 to the 4 to the 8 to the 16, 2 to the 4 to the 8. Okay, so whenever we make the sum of this product, so what is that? 4 plus 1 5 plus 8 13 plus 16 29. So 29 is the decimal form of that binary number. Understood? Okay, so just try the more example of this conversion, means from binary to decimal and from decimal to binary. Okay, and if you have any problem, any query, you can ask me. Okay, thank you.